can be so many different things, and it doesn't even tell you the basis of what it's made from, let alone how it's going to perform. So instead of having everyone just order the red stuff or smell it or look at it or I don't know, taste it, I don't know what they're doing. We figured we'd do a little bit informational session on why greases maybe aren't based off color and what they're really based off of. Sounds about right, Jasmine?
Yep, definitely don't taste it. Taste it.
No, don't taste it. Not kid friendly.
Yeah.
So we brought Greg on board here. Greg is a heavy duty specialist with Valvoline. Oh, we should say who we are too. I am a senior business development manager with SC Fuels. My name is Marissa Mattern, and Jasmine is?
We're the same. So I typically cover the LA, Orange County area. Marissa's up north in Ventura. So we're putting this together to just have some kind of informational, everybody's retooling right now. Everybody's trying to figure out the best way to manage their fleet, especially in these times. And so I think having Greg on would be, is such a great resource for us. So thank you, Greg.
Yeah, thanks, Greg. Go ahead. Take it over.
You are welcome, and I am honored to be invited. I think it's a great idea that you gals have done to put something like this together. And I'm muting my phone so I don't get some background. Are you going to record this? Is that the plan, or have you already started recording?
Oh, we just started.
Okay, good deal. So, all right, I'm going to minimize some screens here just to try to give a little acreage back to those viewing, and everyone else can also minimize your screen. And I believe there's also a chat function. So if anyone has some questions, you're welcome to add those questions to the chat. So again, I think it's a great idea. It's unusual times we're working in, and for you gals to create an environment where folks can kind of check in, learn a little bit, then record it and push it out to those whose schedule didn't match up to what we're doing. Quite creative, and I admire that. And like I said, I'm honored to be the one here. So the following is a discussion. It's not really a formal training. And as such, my comments, my answers, my analogies, they haven't been reviewed by Valvoline's legal or technical or marketing team. So anyone listening should consider this information to just be an informed opinion, not really a product recommendation for their specific application, because grease is pretty critical. And so even though I'm calling it a discussion, I'm going to be moving pretty fast so I can stay within a considerate time limit. So if you got a question, you can jump in, you can put a chat, you can wait to the end, whatever. I expect that my presentation will take about 20 minutes, and we are recording it. So if that time frame doesn't work for you, you can just drop out whenever you need to and then listen to the presentation later if this topic is of interest to you or other folks within your organization. And also, since it's not really a true discussion, you're going to oftentimes see the answers on the screen at the same time that I ask the question. So for today, the questions are largely academic. So if you're ready, let's go. All right, so the first thing is, what is grease? Well, you can see the answer in red is the oily stuff that doesn't move. And the reality is that everyone would use oil if they could, because oil provides the best lubrication boundary between metals that are either sliding or slamming together. And the best, but the problem is that oil, as great as it is, doesn't stay in place. It runs out, and grease doesn't. So that's why folks tend to go to grease when they have to, when oil is not the answer. So what makes oil different from grease? Academic question number 2. Well, the answer is it contains a thickener. And the third academic question would be, what's the role of a thickener? Well, one way to think of a thickener is like the sponge when you're doing dishes. So imagine a sponge in your thickening system, or in your dishwater system, which holds the water and the dish soap. Well, those are comparable to the base oil and the performance additives that you find in grease, respectively. So when you squeeze a sponge, which is a thickener in this analogy, the soap and the water squish out. And when you release the pressure, the soap and the water can be absorbed back into the sponge. When a sponge is dry, a sponge doesn't weigh very much. So the volume of a wet sponge is really the liquid. The weight or the volume is the liquid. And the same thing with the grease, right? The volume of grease is really the oil that's contained. So that's a clue to an upcoming question that I probably won't give you time to answer either. But for now, let's stay on the topic of thickeners. So, oh, there we go. So there are a couple types of thickeners. So greases are primarily classified by the types of thickeners. There are two major families, soap and non-soap. And you can see my screen, you can see I just highlighted the soap thickeners. Our ancestors used to make soap, cleaning soap, from potassium hydroxide, which they obtained from boiling campfire ashes in water. And they mixed that liquid with animal fats. They let that mixture cool, it hardened up, and they made soap. Well, soaps for grease are made in a large degree in that same way, but there's a lot of similarities, but of course, it's much more sophisticated, right? So more than 90% of thickeners used worldwide are just what they call simple soaps. But soap that is thickened in a more sophisticated manner is called complex soap. And that's the most common type that's used in North America, with lithium being that base compound. Now, non-soaps are split into four main groups, or into two main groups. And the first is thickeners that undergo a chemical reaction. And it's, you'd have to be a chemist and you'd have to be a bit of a geek to really get into that. But what this does is these thickeners historically have provided pretty good performance characteristics that the soaps historically couldn't do. One of the problems with these thickeners is these, I'll call them exotic thickeners, is they weren't very compatible, right? Historically, the more performance you got out of the grease, the more expensive it was, and the more likely it was to be incompatible with other thickeners. And again, on a historical basis, lithium have been cheaper. Lithium-based greases have been cheaper. They've been more compatible, but they haven't delivered the performance that the exotic greases like aluminum and barium and calcium, bentonite clay, polyurea, etc., have delivered. All right, but you'll notice on this screen there are four iterations of lithium. You'll see lithium stearate, lithium 12-hydroxy, lithium complex, and on the far right, you'll see lithium sulfonate complex. So lithium sulfonate complex is a fairly recent technology, but you'll see a lot of green in this far right category that represents compatibility, whereas red is incompatible and yellow is it's marginable. It may or may not be. And you'll see on, again, some of these exotics, a lot of red, reinforcing what I mentioned a few moments ago about their incompatibility. All right, so we're going to talk a little bit about grease functions. And interrupt me if there are any questions that pop up. Otherwise, I'm going to keep moving fairly fast. So what is grease? Yes.
So for all the incompatible ones, what would you recommend if you were trying to switch over?
Yeah, so staying within a lithium family makes a lot of sense from a price point, from a compatibility point, as long as it meets your performance needs, right? So if you, and I'll talk a little bit further, if you don't have, later on, if you don't have a real high need, you can get away with a cheap grease, right? A cheap lithium performance grease. If you historically, if you've had a high performance need, maybe it's water washout, corrosion, extreme pressure, high temperature, there are many categories that would fall in that performance need. You historically have had to go to these higher priced aluminum, barium, calcium, clay, polyurea, etc. type stuff. So yeah, whenever you can go for cheap, as long as it meets the need, I like that. That's kind of what the goal is for us as lubrication marketers, is to help our customer get the best value, whatever form it takes. So again, going back to the what does grease do? How does it function? Well, it's a lubricant. It prevents wear. It reduces friction. It reduces oxidation and thermal degradation. And oxidation comes because of high temperatures. Oil breaks down as it is exposed to high temperature in the form of oxidation. It also, grease protects against rust and corrosion. It acts as a sealant, so it kind of keeps out contaminants. And in fact, it tolerates mild to moderate contamination, whether that's water contamination, dirt contamination, or chemical contamination. I mentioned earlier that oil bleeds out, but grease doesn't. And it can help minimize lubrication frequency because of its structure. So grease is really a necessary and good development in a lubrication scheme. So some of the things that you girls were talking about right at the beginning, color. What does color tell you about quality? Well, the answer is absolutely nothing. what does smell tell you about quality? Other than maybe helping to identify that the grease is old, that it's been heated excessively and is now cooked and old, it probably doesn't tell you a great deal. And some folks do put fragrances in greases and others don't. Are there any benefits to color? Well, sure. Some of the white or neutral color greases make sense in manufacturing. Say if you're Black & Decker and you're making drills, you need a little grease. Well, there's no reason to have it a colored grease. You might as well go with just a neutral color. Sometimes in inventory, folks do want a colored grease so that either blends in with their equipment or it stands out depending upon their need. Some folks don't like black greases for that particular reason because they may have beautiful, bright yellow construction equipment and they got black grease oozing everywhere. And if they could avoid using black grease, that might be something that they choose to do. So I mentioned the whole sponge analogy earlier, and that's going to kind of answer for you the question that I would normally pose during a grease training class, which is, what's grease made of? And most people get these first two categories absolutely backwards. They think that thickener comprises the majority, 70 to 95% of grease, and oil is the minority, 3 to 30%, when in fact oil, like in the kitchen sponge, water, comprises the largest share of the volume, whether it's mineral oil, synthetic oil, or bio-based fluids. And the thickener provides a much smaller percentage, whether it's a simple or complex soap or non-soap thickener. And then you have a very small sliver that is the additive package. And those additives help improve the grease for desirable properties, such as extreme pressure or corrosion or water washout or tackiness or smell even, right? And all that combined makes the lubrication grease. Again, a little example of some of the things that the additives do: extreme pressure, anti-wear, rust inhibitors, oxidation inhibitors, metal deactivators to keep from rust and corrosion occurring. When I'm talking grease and I'm trying to help someone decide what's the right grease for their application, obviously we take a look at what the OEM requires, but we take a general look at what I consider the three leg on a stool analogy, or three legs of a stool. A stool needs at least three legs to sit well, and those three legs should be proportional to each other. So I use performance, price, and pumpability. If you don't need a high performing grease, you can get by with a cheap grease. If your application is hot or corrosive or extreme pressure or long drain and long service intervals or whatnot, you might need a performance grease. And if that's the case, you might have to be willing to pony up and pay a higher price than the cheapest grease that's being offered to you because of the difference in the performance gap. Pumpability is a third thing. Historically, high-performing greases had pumpability problems, and that if it got cold, they just didn't pump quite so well. But new technology has largely solved that, at least for the Valvoline high-performance products, as we're able to use thicker oils, which provides a thicker lubrication boundary, and at the same time, we engineer it such that it does perform quite well. So why grease matter in grease selection? Well, product consolidation generally makes folks' life easier, not having to stock multiple types of the same or similar product. Choosing the right product for the application, maintaining the original equipment manufacturer's warranty, or maybe extending a drain service interval. I'll pause, see if any questions have come through chat or anything.
A question I read is they want to know what signs are that they're using the wrong grease. Are there any signs that can stand out that they're using the incorrect grease for their application?
Yeah, great question. It ranges from simple clues to more sophisticated clues. I'll start with the sophisticated. We can actually take a grease sample and do an analysis, similar to an oil sample, an engine oil sample, hydraulic oil sample. So we can review that. They'll put it through the specific test, and they'll look for breakdown in the base product. They'll look for the oil maybe having been oxidized or burning up. They'll look for metal shavings or wear or signs of acid buildup. I mean, there's a lot of tests in there, so someone could really take a look at that. On the simple side, you could look and see that your grease is just running out. I've had customers who say that they grease equipment. One customer down in Imperial County excavates the water channels because Imperial County of California gets no rain. All the water comes from the Colorado River. And they at one point were excavating those, they were greasing their equipment 3 times a shift. And now they're down to greasing their equipment 1 time a shift. And so that would be an indication that the grease that they were using was just running out, while the work was being done. So that would be one thing. Excessive wear, and of course, everyone has to establish what their norm is. I've had people that say we replace pins and bushings on equipment once every 6 months, once a year. And others go, well, we don't replace them, but once every 2 years. And, that's a function of number of hours on the equipment, but it also might be directly connected to the quality of grease that they use. So again, simple to sophisticated methods exist for determining whether or not you're using the right grease. And we'll talk a little bit about how you can evaluate a grease in just a moment. So I mentioned consolidation. Some greases like black greases, greases that have the molybdenum additive, they can't be used for on-road or they void warranties. So again, finding the right product is a good thing. So how could a grease product or a better grease product help the end user? Well, under preventive maintenance, a good performing grease might not be squeezed out of the application as quickly, and therefore you could reduce the amount that's used at each service or the frequency of the service. And for reliability, and Marissa, this gets to your question really, a good performing grease can extend the life of the bearings, the U-joints, the kingpins, tie rod ends, pins and bushings, all the various components that need to be greased and lubricated on-road or off-road equipment. And the last thing, changing technology is a big deal because we've seen a great deal of technology changes in both industrial, in on-highway and off-highway applications. And what's happened is that power densities, as they're called, or loads are on the rise. Temperatures on loads, on grease joints, on bearings can be on the rise as well. And examples of that would be like smaller tractors, excavators, skid steers. They have more horsepower than they've ever had before. And they're using, these small units are used to do the work that larger equipment of the past used to do. Well, that usually comes with higher shock loads, higher temperatures, and better greasing, among other lubrications, probably are required. On highway fleets, the biggest change is tied to longer service intervals. We've seen engine oils, transmission oils, drain intervals extend. Gear axles, went from 100,000 to 500,000 miles, 750,000 miles. All these service intervals are being extended. And if you're participating in extended drain intervals, whether it's on-road or off-road, you need the right grease, or what you're doing is you're sacrificing your equipment because you're touching it in the shop less than you previously were. Now, when we look at greases, every grease out there has what's called a product data sheet. You can see that off to the right-hand side. This is one of our greases called Cobalt, and you can see their basic properties on the left. The thickener, what's being used. Is it one of the exotics like aluminum or calcium, or is it a lithium or something different? What's the consistency of the grease? Is it number 1 grease, number 2 grease? Is it thinner or thicker? What's the dropping point? Load carrying ability, water resistance, pumpability, rust prevention, high temperature, oxidation stability. So all this information are the tools that Marissa and Jasmine use for helping customers dial into the right grease. They compared that against maybe what the OEM has called for. But the problem is we see it weekly, if not daily. Sometimes the OEM is maybe a European or an Asian manufacturer, and we just don't have that grease there. So these ladies have to cross-reference that spec grease or that recommended grease to something that's locally available. And they use things such as this information, these product data sheets, to help compare and recommend the right grease. And some of the things we'll just focus slightly on are like grease dropping point. That's usually a common one that everyone wants to know. And again, the purpose of this slide is to really show you that some of the exotic greases like calcium and polyurea and aluminum and bentonite clay and sodium, they've got dropping temperatures up in the 500. Well, fortunately, lithium, which used to be kind of a subpar grease, now the lithium complexes and lithium sulfonates are all up in the same category. So again, you're using a cheaper soap that is delivering the performance that the historically higher price greases were you had to buy to get that. Some other ones, you're welcome to take a picture of this and look them up yourself if you're that into it. 4-ball weld, Timken OK, load wear index. There's a couple of things here. We'll look at a few of them. Like the Timken test, it's a pretty common test. And what you see on this is you want, as on the screen, these nice clean scars. What that scar means is that the clean block of steel was put down, the ring, as it's called, started to spin, grease was put in there, and a very small groove was worn away, and then the grease began to do its job and kept the metals from separating. What you don't is you don't want, somebody's getting a delivery and the dog showed up, I guess, but you don't want the look like you see to the right or to the bottom, which is where the metals have ground together, they've welded, they've gouged and spalled, because that represents excess wear. What I do want you to show on the Timken test is 800 RPMs, 10 minutes, and 30 pounds of pressure, increasing by 10 foot-pounds in increments. And they use a continuous supply of grease. Well, 800 RPMs is fairly fast, and 10 minutes is a fairly short amount of time, and 30 foot-pounds is a fairly small amount of weight compared to another important test, which is generally more reflective. It's the ring on block. 300 RPMs, that's less than half of the 800 that we saw. 60 minutes, that's 6 times longer than the 10 minutes of the Timken OK, and 600 pounds is about 20 times longer than the initial 30 pounds. And I think the most important thing is it's a closed sump. So you're not continuously adding a lot of grease there. So what's important to this is this really demonstrates, this digital ring on block, it demonstrates the true working environment for most of the customers that we encounter is slower, heavier, and longer. And again, what you see is a nice illustration. And this is what you want. You want a good, clean, minimal scar, not these ugly wear, because whenever you've got this type of wear, you're breaking off hard particles, and those particles are moving around your equipment and generating themselves excess wear. 4-ball weld, it's another big one. It's a test. What they do is they put 3 balls into a chuck or a cup. It's not a race or a cup. They put a dollop of grease. They put a 4th ball, move it at 1700 RPMs, 10 seconds, and then they keep increasing the load from 6 kilograms up to 800 kilograms, 1,600 pounds. And typically when greases fail, they fail at 250 or 315 or 400 or even 500 kilograms, right? So what happens is when this is all done, they inspect the scars that those balls left. And what you're wanting is you're wanting a little small scar. This is a pretty decent scar, 1.256 millimeters. The Valvoline Cobalt, this is maybe the first time, I think I might have mentioned Cobalt once, that you've heard this. This is our most robust grease, and you can see it's a very small, very clean scar compared to these others. Now, these other greases, these are reputable greases. These are Chevron Delo ESI and Castrol Pyroplex Blue and Mystic JT6 and some Mobile, and I forget what the other one is. I think it might be a Shell grease. Anyways, some pretty reputable greases are represented here, not just cheap, no-name greases. But yet what you see is that this Cobalt is performing as well as maybe some of these higher priced and more exotic greases in this. That's another representation of that. And it shows how the blue Cobalt goes out to 800 kilograms before it fails, whereas these other more commonly known greases, they fail at 400 kilograms or at 250 or ranges below 315 or so. And you saw the kind of the ugly scars that were there. One of the other regular tests, did you have a question?
So you have a video of how this actually works. That
I do, yeah, and we can certainly push that out to you. Anyone who wishes to know could see it. And again, I'm trying to bridge the line between sharing new technologies and not overselling the Valvoline products. We've got good products. Some other people have good products too, but I'm just trying to point out that I guess the primary point is you don't have to spend $8 or $9 a tube to get high performing grease anymore, right? $8 or $9 a tube. You can get really high performing grease for prices that are near the prices of middle of the road greases where they've been historically. So load wear index, you can see again, 150 versus the typical, great performance there. So it's important to understand again about that oil that we talked about. Human hair is between 60 and 80 microns as illustrated on the chart. A large particle might be 15 microns, and that's why we filter oils, right, down to 10 microns or less. The average clearance of a hydraulic component could be in the 10 micron range, a small particle slightly smaller than that, which means that the oil that's being filtered at 5 or 10 microns is smaller yet. Now, again, I mentioned previously that thicker oils are great for keeping metals apart, but they have pumpability problems. And this particular slide also helps us with that whole thicker oil concept. You want that good thick oil to keep the metal, the asperities on the metal, the peaks and valleys from grinding against each other, as like you see up in this very top boundary film slide. You want to keep that fluid film in there to keep those metals apart. And one of the technology breakthroughs on cobalt grease, in addition to using the lithium to get the price down and the sulfonate compounding to get the performance up, is to take very thick oil, improve the pumpability that's been the problem with thicker oil greases. Our process encapsulates the thicker ISO 1000 oil to a very small size. So think of hydraulic oil. Most folks know hydraulic 32, hydraulic 46, hydraulic 68. Well, that thickness, that ISO grade goes up into the thousands, but most greases only have a 220 or a 320 or maybe a 460 oil. Anything thicker than that, it just doesn't pump. But what we've done is we've encapsulated that oil to small gel caplets of the same size so that those caplets rupture when the thick oil is needed, let's say under extreme pressure circumstances. And that thick oil serves to keep the metal parts apart, whether they're sliding or slamming. Now, some of you are familiar how oil can be encapsulated with a water molecule, or water can be encapsulated with oil molecules. And that technique has often been used in fragrance and food and medicine industries. And Valvoline has applied that to the grease lubrication segment of the market as well. This next slide just kind of shows how cobalt, through this thick oil encapsulated thinly, this pressure activated technology is our sales phrase, keeps the temperature down. Again, the same greases that we showed earlier show operating temperatures up into the 300 Celsius range, whereas the cobalt is down in the 100 Celsius range. And these peaks represent those caplets rupturing and the grease doing its job and keeping it running smooth. Well, running smooth also reduces friction, and in some cases by more than 50%. Again, ruptures oil release until oil allows this particular test to go on for a couple of hours. It's the Phalanx digital ring on block at low speed that we talked about earlier. So good new technology brings great benefits, reduced friction, engines or equipment running cooler, and all of that. Valvoline has a lot of products from our least expensive Crimson, red tacky, to the cobalt, and even the products that have 3% or 5% molybdenum for off-road equipment that require that. You'll see this, it's a bit of an eye chart. You can't read it. And it's just a sample of the type of analysis that Jasmine, Marissa, and I put into grease consideration when we're making a recommendation. So if you could read this, you would see the names of Valvoline and Chevron and Mobil and Shell and Schaefer's and Lubrication Engineer and Castrol and many other greases, both cheap and expensive. And on the side, you would see all the ASTM tests, some of which I've already mentioned, things like dropping point, water washout, extreme pressure test, many, many, many more. Okay, if we zoomed into this side, you can kind of see how we've listed here the thickener type and the viscosity index, which is important, mobility, pumpability, whether or not it contains additives or not, 4-ball weld, corrosion, etc. So back to the slide, you'll notice that there are a lot of colors. So what I've done with this slide over the years is if a grease has been really poor or sub-industry performing, what I'll do is I'll highlight it in red. If it's been superior, I'll highlight it in green. And you can see a variety of green, better than industry indications across a wide number of greases. And you'll see a handful of reds, less than industry average are highlighted there. And you'll see a lot of whites, which are just industry and average. But you'll notice that one grease in the middle has proportionally more of the better than industry green highlights than any other ones. That's the cobalt grease. Now, cobalt may not be the right grease for your operation. It quite frankly just may be overkill for what you do, and that's okay. Jasmine, Marissa can help you find the right grease so you meet the lubrication goals of your organization as you keep the three legs of the stool in balance. So just again, a little reminder here. What we're looking at doing is not to get wear scars that look like that on your equipment. We want good, clean wear so that we have minimal wear so that your equipment goes the full life that you want it to go to. Even popular greases may not be the best grease for reducing wear. So when you can get access to a grease that's superior in so many areas, from corrosion to wear to water washout to pumpability, it may be beneficial to reevaluate your grease selection. So that's the quick, as quick as I could, as talked as fast as I could, run through of a little grease basics, as well as an explanation of some of the improvements in grease technology. And I hope that was beneficial to you. And with that, ladies, I will turn it back over to you, Marissa or Jasmine.
Going back to water washout, do we still have someone from City of Long Beach on? Maybe not. But you mentioned that that's something that cobalt can handle. What exactly is the composition of the grease that makes it better for water washout?
Yeah, so there's a couple things. You may recall seeing the word sulfonate in there. And in the West, this is an analogy that most people understand. Other parts of the country, it's not common. You know how a lot of folks have, what do they call them, swamp coolers or evaporative coolers?
Uh-huh.
And you can go to Home Depot, you can buy a cheap pad, and there's not a lot of fibers in that pad. It contains some fibers and the water run through it, but the evaporation, the surface area is fairly minimal, and you only get a limited amount of cooling. Or you can step up to a higher priced, high dollar, higher quality pad, and you've got a lot more surface area in there. Well, that means that you have more evaporation going on, which makes your swamp cooler or evaporative cooler more efficient, right? So that's kind of like the sulfonate additive or the sulfonate properties in cobalt. Using sulfonate has historically been one way that they could improve the water washout properties of grease. And again, historically, you've had to go to a calcium sulfonate to be able to get that particular property. Now we can do it with a lower priced, more compatible lithium property. So sulfonate is certainly, that technology is one benefit for water washout and corrosion protection. And all corrosion protection means is that grease and oil, that thickener and oil, provide a protective layer between the metal and the corrosive property, generally it's salt water, right? So when you have that good protection layer, what happens is your metal just doesn't rust near as quickly. So it's kind of water washout and corrosion protection are kind of hand in hand type of properties.
Got it. Thank you.
So Greg, I know that lots of my heavy duty customers do need to use greases that include moly in it. Do you mind explaining exactly what moly is and what it would do if you were to use it in applications that didn't call for it?
Yeah, absolutely. Thank you. Another great question. So moly has been around for many decades. I don't know if that number is 4 or 5, if it's 40 years, 50 years or more. But you can imagine Caterpillar in particular, as they created equipment and sold it throughout the world. And not every region of the world had good uh, distribution of lubricants and good maintenance practices. So putting moly in a grease, moly's a mine mineral. When it's pulverized, it plates out like fish scales. It is kind of a second line of defense. It's kind of a fallback. So once the grease process has been neglected, and the grease and oil have worn out and bled out, that solid lubricant of molybdenum is still there for some period of time. And so it is something that is required by CAT under warranty. Another example would be like a really large excavator that has a small grease keg, maybe 120-pound grease keg at the back, but yet it's got these very thin spaghetti lines that go to the very front of the excavator. And they use maybe a double R or even a triple R grease. They're going to put moly in there so that that grease can, so that there's the lubrication is occurring by the presence of the moly, because the grease itself is very, very thin. So under warranty, you're welcome to encourage to use moly. Some users just absolutely hate using moly because it tends to collect dust and grit. And to that end, on-road users, slack adjusters that are used in on-road trucks, most of the manufacturers, Webb, Haldex, Accuride, etc., they specifically prohibit you from using greases that have moly in there, because they don't want that moly to build up and cause those slack adjusters from ratcheting forward or adjusting forward, and therefore compromising the braking reliability of their adjusters in on the trucks that are in there. So you've got to be careful. Now, the bottom line in testing is that cobalt performs just as good as the greases that have moly, just as good as Valvoline's 3% or 5% moly, just as good as the other name brands that I mentioned, 3 or 5% moly, and just as good as the high-priced specialty greases that have historically stepped in and tried to help solve the performance problem.
Perfect.
Good.
And nice to just be able to have one product instead of several. So thank you for that.
You're welcome.
Jasmine, do you see any other questions in the chat?
I don't see anything. Does anybody have any questions for Greg that he can answer right now? Okay. And I know that we promised samples for this one, so if you could please include in the chat where you'd like us to send it to and who to attention, we'll give out some samples. The thing is, Greg, is there a way, I guess, to figure out how to actually do like a battle test with the greases?
Absolutely. Every business has an application that it's just a headache, and they know what those applications are. And so our encouragement is take your worst application. I mean, for some folks, it's been like metal crushers. They've said, we've got this 17-inch bearing that fails every 6 to 8 months. And I say, all right, next time you get a bearing, have it sent dry with no grease in it, put cobalt in it, and tell me how it does. And then, they're 2 years on and they're like, everything's great. Where somebody else says, well, I've got this in every, 6 weeks or 9 months, or, whatever there is, their situation is, it wears out. And I'm like, next time use cobalt. And so that's the best situation, is if you have a problem category, isolate a piece of equipment, use the cobalt in it, and if past experience indicates and can predict the future, your operators are going to go, I used to make 4 or 5 or 6 pumps to fill it up with grease. Now I'm making 2. Well, that indicates that you're using your 2/3 less grease than you previously did. And then your mechanic is going to say, well, I normally would be looking at replacing this part about this time. And when we took apart and looked at it, and we've seen this in the trash industry, pins for Corrado cans or parts of the Python arm and whatnot, they'll look at those and they'll go, hey, we're 3 months on using cobalt, and you cannot tell that this isn't a brand new pin, a brand new component, whereas we normally would be replacing it by this time. So that's probably the best way to do it is isolate a problem area, use the cobalt, and be pleasantly surprised.
And next week's topic is going to be on coolant.
Coolants. Is it going to be next week or in 2 weeks? What's your scheduling?
I believe we have it down for next week. Is next week? No, it's not. We're not to Memorial Day yet. I don't know why I'm at the end of the month already.
That's right. And that's good, because kind of what's interesting is light grease technology has improved, and like engine oil technology, both gasoline and natural gas and heavy duty diesel has improved. Coolant technology has improved too. The red coolant that most of us think of as the new stuff, that's 20 years old now. And so we've got some good coolant technology, and looking forward to sharing that with the group as well.
Same. So next week's 11 a.m. Pacific time on Wednesday, we will get to chat with you guys all so much about coolant. Thank you guys for joining us.
Don't forget to email us if you'd like that sample, so you can do the ballot testing with your plate.
Thank you.
Thanks, everyone.
Thanks for the chat. And Jasmine, send me the information on the next ones, and I'll make sure and promote those.
Perfect.
Thank you.
Marissa, both of you.
Yeah, nice to meet you, Marissa.
Did you have any questions? Was this helpful? I hope that it was something that...
Well, I learned a lot, I can say that.
Yeah. Perfect. Well, thanks, everybody. Have a good one.
Thank you, guys.
Thanks a lot. Take care.
Bye.
Bye-bye.